So I know last night's homework, the perpendicular lines, was a little tough. There was some challenging questions on there. We're just going to do one more lesson, lesson 3. And then on Friday, I'm just going to have you do practice, and then I'll be back the next time you have school, which is on Tuesday. So what I would like you to do first before we get into the lesson is just go on Google Classroom and take a look at the answer key I posted for the homework. So if you go again to classwork, scroll down a little bit, you'll see Unit 1 answer keys, click Lesson 2. And then if we take a look at 1-2 homework answer key, here is the answer key, and you can check that out on your own. I know it's difficult right now because I'm not there to answer your questions, and I know we're all doing the best we can. That's why I'm going to slow down after this lesson, and we'll continue when I get back. So we are just going to take a look at one more lesson. It's parallel lines. So that's lesson 3 in your notes, and we'll go from there. So first question in exercise 1, part A, says name the pairs of parallel lines. So you should remember parallel lines. That would be these lines here are parallel, or look to be parallel. And then these lines here look to be parallel. So I'm going to say R, and then I'm going to show you the symbol for parallel. It's 2 vertical lines. R is parallel to N. And additionally, we have M is parallel to S. It says determine the slopes of the 2 lines that make up the pair. So we're going to find the slope of R, the slope of line N, the slope of M, and the slope of S. Okay, so the slope of R. I'll go start here and go to this point. So that's going to be down 1, 2, 3, 4, 5, right 2. Down 5, right 2. Let's look at N. So I'll go from here to here. Down 1, 2, 3, 4, 5, right 1, 2. Let's do M. M is up 1, 2, right 1, 2, 3. And S is up 2, right 1, 2, 3. So both of those would be up 2, right 3. Okay, so now we're going to take a look, see what we notice. What seems to be true about lines if they are parallel? So the slope of R and the slope of N, they're both -5/2. The slope of M and the slope of S, which are 2 parallel lines, they're both 2/3. So I'm going to write here, if lines are parallel, their slopes are the same or equal. So 2 non-vertical lines will be parallel if and only if they have slopes that are equal, the same, whatever you want to call it. Okay, so yesterday we saw perpendicular lines. They have negative reciprocal slopes. Today we have parallel lines and they have the same slope. So in exercise 2, it's asking us to determine if AB is parallel to CD. Well, let's go ahead and find the slope of AB. Now, I don't have a grid here, so I am going to use the slope formula, which is y2 minus y1 divided by x2 minus x1. All right, so here are my y's, and here are my x's. Okay, so I can do 7 minus 1 over 6 minus a -2. And that's going to be 6/8, which equals 3/4. So now let me find the slope of CD. So I'm going to do the same thing, but this time I'm looking at C and D. Here are my x's. Here are my y's. So y2 minus y1 over x2 minus x1. That's going to be 9/12, which reduces to 3/4. So I could see here that the slopes are the same. So I'm going to say AB is parallel to CD because they have the same slope. Okay. Let's do the same thing now to determine if AC is parallel to BD. Okay, AC, and we'll do that one first. Okay, so slope of AC. That's going to be -3 minus 1 over -4 plus 2. And that's -4 over -2, which is just 2. Slope of BD. So here's my x's. Here's my y's. Y2 minus y1 over x2 minus x1. So that's going to be -1 over 2. So I'm looking at the slopes, and I'm seeing one is a slope of 2, one is a slope of -1/2. So they're not equal, so they're not parallel. I'm going to say no, AC is not parallel to BD. Well, what are they? They're not parallel, but they do have something interesting about their slopes. One is 2, one is -1/2. They're actually perpendicular. So we actually could see that AC is really perpendicular to BD because they are negative reciprocals. Okay. All right, and last one here in this exercise. If point E exists such that its x-coordinate is 12, so I know for point E, I know the x-coordinate is 12. I don't know anything about the y-coordinate. I'll just call it y. We do know that ED is parallel to AC. Then what is the y-coordinate of point E? So they tell us here that ED is parallel to AC. So you have to ask yourself, what does it mean if the lines are parallel? If we know that ED is parallel to AC, then that must mean that their slopes are equal. Okay, let's look at what AC's slope is. The slope of AC, we found earlier above, the slope of AC is 2. We found that out right here. The slope of AC was 2. We'll just continue on with that. The slope of AC is 2. That must mean that the slope of ED has to also be 2 because they're telling us they are parallel. Okay, we have to figure out what the y-coordinate of E is. We know the x-coordinate is 12. We know what the coordinate of D is, right up here. It's 8, 6. We know what D is. We know what part of E is. We know the slope of ED. Let's just set up an equation. We know that the slope formula, y2 minus y1 over x2 minus x1, we know that has to equal 2. So let's make some substitutions. I'm going to do 6 minus y, I don't know what it is, over 8 minus 12. Okay, I'm going to simplify this a little bit. 6 minus y over -4 equals 2. So in Algebra 1, when you had something like this, you might have cross-multiplied, or maybe you multiplied both sides by -4. So that's going to give us 6 minus y equals -8. I'll subtract 6 from both sides. I have -y equals -14. Okay, so y has to equal 14 That must be the y coordinate. So this was a little bit of an involved question because you had to use the information they gave you. All right, we have a couple of quick questions here, and then that'll be it. So in this multiple choice question, it says, which of the following represents the equation of a line parallel to one whose equation is 2y plus 8x equals 18? Let's figure out what the slope of 2y plus 8x equals 18 is. All right, so I'm going to subtract 8x from both sides. And then I want to get y by itself. Y equals negative 4x plus 9. Okay, that's in slope-intercept form. I want to come up with an equation that is parallel to this. So hopefully you're looking at this equation, you're extracting the slope and saying I need a line parallel to that, so I need it to have the same slope. These are not the same slope. It's going to be choice 1. Choice 1 has negative 4 as the slope. Which equation represents a line parallel to the x-axis? Okay, I'm going to draw this out. And here's my x-axis. So parallel to the x-axis. We need a line then that is horizontal. So we're looking at a line that's horizontal. Maybe it's here, maybe it's here. But we want a horizontal line. Horizontal lines are going to be y-equal lines. If you're unsure about that, what you could actually do is in your calculator, if you weren't sure if the line was horizontal or vertical, you could go and just put in a line. So y equals 5. Let's just take a look. Okay, horizontal. All right. And this one here. The student wrote the following equations. The lines represented by these equations are what? Are they parallel? Are they perpendicular? Are they the same exact line? Or, hey, do they just intersect but they're not perpendicular? So to figure that out, we do have to go through, we have to take both of those equations. I would get them into y equals mx plus b form, and then we could determine what the slopes are. 3y plus 6 equals 2x. So I'm going to subtract 6. Then I'm going to divide by 3. And we get y equals 2/3 x minus 2. Okay, let me do the other one now. 2y minus 3x equals 6. So I'm going to add 3x. And then I'm going to divide by 2. So I have y equals 3/2 x plus 3. Let me highlight the slopes. And then we'll go from there. So 2/3, 3/2, they are not the same. They are not the same slope, so they are not parallel. They are not negative reciprocals. They are reciprocals, but they're not negative reciprocals, which means they're not perpendicular. They're not exactly the same, right? It's not the same exact line, so it's not that, which means they intersect, but they are not perpendicular. Okay, and the last question here that I'm going to do with you is pretty much the same thing. We have to figure out what statement is true. It looks like there's a little error here with the symbols. This should be perpendicular. This should be perpendicular as well. So if yours came out like that as well, just fix that to be perpendicular. Okay, I'm going to take each one of these, get it into mx plus b form. So for k, x plus 2y equals 6. I'm going to subtract x. Then I'm going to divide by 2 to get y equals negative 1/2 x plus 3. Next one, p 6x plus 3y equals 12. I'm going to subtract 6x. Then I'm going to divide by 3 to get y equals negative 2x plus 4. And the last one, m, negative x plus 2y equals 10. Let me add x. Let me divide by 2 to get y equals a half x plus 5. Okay, I'm going to highlight all the slopes. So looking at all these slopes, we kind of want to determine what statement is true. It doesn't look like any of them are the same, which means that we don't have any parallel slopes. We don't have any parallel lines. But what I do notice here is these two slopes are negative reciprocals. Since they are negative reciprocals, that means line M and P are perpendicular. Okay, so this was a little bit of a shorter lesson, which is fine. So your homework tonight is lesson 3, 1-3. Try your best with it again. If there are some questions that you don't know how to do, that's fine. Just submit to me whatever you are able to do. And then tomorrow, we're not going to do anything new. I'm not going to make a new lesson. I will make another video, though, just to kind of explain what I want you to do on Friday. But it's not going to be any new content. And then I will hopefully be back on Tuesday. I should be back on Tuesday. And we'll go from there. All right, so I appreciate you guys. I know it's been kind of a rough beginning to the year, and I thank you for trying your best, and I will be back soon. All right, have a good day. Bye.